Alright, hopefully you've already watched the more basic video on one-sided limits, but basically, a lot of times we're talking about limits where you're approaching a number from both sides at once. So you just have the limit as x approaches 2, you're saying, hey, let's approach 2 from both sides simultaneously. Where does it look like we're going to collide, coming from both directions at once? But if we put this little sign, negative sign to the right, like we have right here, or plus sign to the right of the number, that doesn't mean positive or negative. What that means is a negative sign means coming from the left, so you'd be coming in this way, and then the positive sign means from the right. So we're just breaking up the left and right collision course into one side or the other, because a lot of times a function won't approach the same thing at the same time. You might have an asymptote right there, to where when you approach the asymptote from the left, you're shooting up like crazy, and then when you're coming from the other side, you shoot down towards negative infinity. So these are a total mismatch. So that's why we'll be talking about left and right separately. It's kind of like a way to talk about asymptotes a little bit. Alright, so let's see what happens. As usual, first thing to try, what is it? Always plug in first. So even though this function here clearly has an asymptote at x equals 0, 0 is not where we're plugging in. They're asking, hey, what's the limit from the right at 1? Now there's probably a trick question. They're hoping they're going to try and come up with something crazy, when in fact it could have just plugged in 1 and gotten 1, right? Because 1 over 1 is 1. If a function is continuous at the number you're looking at, like 1 over x just passes right by 1 without noticing it, 0 it has a problem with. But when you divide by 1, that's no big deal. So whenever you're in the sort of a middle of a function that's just smoothly going along, even if some crazy stuff happens over here, if you're still in the smooth part where it's just a rocking line, just plug in the number. It shouldn't be a big problem. Where plugging the number is not going to work is when we end up dividing by 0. Then we get nervous about the left or right. But this one again, 2, it doesn't matter if you approach 2 from the left or right, either way plugging in is going to work. We just plug in 2, we get 2 minus 6 over 2 plus 1. So that's negative 4 over 3, or negative 4/3. So the reason 0 is going to be a problem is because when you divide by 0, that means infinity, right? And now we're going to have to, it's going to be a little bit tricky. We'll have to figure out if it's going to shoot upwards or downwards. And that's what we'll get to in a second. All right, this one again, this looks funky, and actually right now it's indeterminate. But it's not infinity. It's just indeterminate. So if we do more work on this one using the square root techniques I showed in the last video, it should work out okay. And the square root technique on this one is going to be multiplying by the square root of x plus 1. So that'll give us x minus 1. If I'm moving too fast, watch that radical limit video. And then we've got x minus 1 times square root of x plus 1. And la-di-da, the x minus 1's cancel. And now we can really just plug in 1 because we get 1 over 2. Alright, so that one worked out, even though it was indeterminate at 1. So when we plugged in 1, we got 0 over 0. It was indeterminate. Again, left or right, not so much a big deal for this one. If we had gotten something else over 0 and got infinity, then the question is it positive or negative infinity? Alright, so when we plug in and get 1 over 0, or a number over 0, not indeterminate, just infinity or does not exist, now we got a problem. Now in previous limit sections, when you get something divided by 0, like in this one we plug in 0 for x, we get 1 over 0. And we just said, hey, you know what, that limit does not exist. Maybe we said infinity, but the point is that we just said does not exist. But for some reason on this left side versus right-sided section, and as soon as you throw in a little plus sign to the right of it, now infinity or negative infinity is an okay answer, and you'll actually have to figure out which one it is. Is it plus infinity or negative infinity that this limit is approaching? So what we've got to do is just figure out, hey, if we're approaching from the right, how do we do it? Now in this case, 1 over x, I've got the graph right here on the right. Even if I didn't, I should know off the top of my head from the parent functions chapter of precalculus that this is what the graph looks like. So, you could use your calculator also if you're allowed to use calculators. The graph looks like this. So what am I approaching? Well, if I approach 0 from the right, so coming from this direction, my function is shooting off towards positive infinity just to the right of 0. So this is actually not going to be 1 over 0, it's going to be positive infinity. And a lot of teachers want you to put that plus in front of the infinity just to let them know, hey, I knew it was positive infinity. I didn't just like put down infinity because I didn't know. Approaching 0 from the left on this one though, see how this is going towards negative infinity? So that means the left and right limits are actually different. Neither exists. but one is shooting upwards without bound, one was shooting downwards without bound. And then I just put this last one on here. It's not a one-sided limit, it's just a regular limit. This is definitely a does not exist. Because the problem is that because this and this don't match, then it's no limit. All right, here's another one. We got the graph again. Let's see what happens. All right, so we've got the graph, and we should be able to deduce this graph anyway using techniques from pre-calculus. You'll notice we probably have an asymptote at x equals 2, because that's what would make the denominator equal to 0, and that's how we got this as a vertical asymptote. And of course 2, they would pick the number. X approaches the number 2, which happens to be the number that makes this an asymptote. So that's a bummer, but of course that's what they do to you. They never pick the easy ones usually to give you on quizzes and tests. So we know there's an asymptote at 2, but of course you wouldn't want to just figure, oh, approaching 2 from the left, it's probably negative infinity like that previous problem. You want to plug in a point and see what you get. And my recommendation would be to plug in something really close to 2 that's on the left side of 2. So you see right here we're approaching 2 from the left. What's just to the left of 2? If here's 2, what would this point be? Maybe 1.99, just to pick a random number. Now if you have a calculator, you could actually plug it in. You could plug in 1.99 minus 6 over 1.99 minus 2, and you'd get a number. I don't know what that number is, because I'm going to show you how to do it without a calculator. What I would do is figure, you know what, 1.99 minus 6 is like negative 4. But then what's downstairs? Is that a plus or a minus tiny number? 1.99 minus 2 is a tiny, tiny, tiny number. But it's actually a negative tiny, tiny number, right? Negative 0.01. The reason it matters if it's plus or minus is that negative sign downstairs is now going to cancel this. And we'll get 4 over 0.01, which is a big number, like I think 400. So, does that mean we're approaching positive infinity or negative infinity as we approach 2 from the left? Well, we plugged in a number just to the left of 2, and we got a really big positive number. So that means we must be approaching positive infinity. And again, I know the limit's infinity, not like 400 or 500 or 1,000, because I already know there's an asymptote at 2. So the only question is it positive infinity or negative infinity as the limit? You know it's one or the other. It's not going to be just a big number. It's going to be positive or negative infinity. So once we got a big positive 400, we know that's a positive infinity as the limit. Now approaching 2 from the right, I can pretty much guess that if I had a positive infinity on one side of the asymptote, I'll probably have a negative infinity on the other. But of course, what if you had made a mistake in this first one? It's better to work it through and actually find out. And then if your answer ends up matching your assumption, then that's great. And if it doesn't, you can now know that maybe you got it wrong, and you should go back and double check the first part of the problem too. All right, and by the way, usually on either side of an asymptote, one will go up, one will go down. The times where you'd have either both going up or both going down tend to be if there's a squared. So like if this had been x minus 2 quantity squared downstairs, or there'd be an x minus 6 quantity squared upstairs, that's the kind of thing that would cause a friendly asymptote where both are going in the same direction. If you're confused about this asymptote stuff, definitely check out the pre-calculus chapter on graphing rational functions, because that'll talk all about asymptotes, unfriendly asymptotes, how to graph them, and that kind of stuff that I'm kind of going through fast right now. All right, so the point is that limit as 2 approaches from the right, we're going to do the same thing. We'll pick a number. If we're approaching 2 from the right, I want a number right next to 2 that's just to the right of 2. And it looks like that would be 2.01. So I'm just going to plug in 2.01 for x everywhere I see it. So it'll be 2.01 minus 6 and 2.01 minus 2. So once again, I'm going to get negative 4 up top. But downstairs now, I'm going to get 2.01 minus 2 is just 0.01, right? So that's actually, I have a negative sign upstairs still, but I now have a positive tiny number downstairs, which means I'm going to get negative 400 in this particular case. So you notice I have a big negative number. That means my limit is negative infinity. Once again, your limit is either plus infinity or minus infinity on either side of an asymptote. You just got to figure out which. And plugging in tiny numbers is a great way to go, or numbers that are really close to the asymptote. All right, so once again, this one, on that last one, I kind of gave us the graph to sort of give you an idea what that function looked like. On this one, I'm not giving us the graph. I have no idea what this graph looks like. x squared minus 1 plus 1, whatever, I have no idea. But it doesn't matter for a limit problem. We're not going to have to go through and find all the asymptotes and all that stuff. All we have to do is realize, you know what? We're approaching 4, and 4 is also where I have an asymptote. I know that because, the denominator becomes 0. So I know that my limit approaching 4 from the left is either a plus infinity or a minus infinity. I just got to figure out which one. Now, what's the one time that this won't happen? Well, if we have an x minus 4 downstairs, but then an x minus 4 upstairs, like if the top had factored x minus 4 times da-da-da, then these would cancel and it would just be a whole or removable discontinuity at that point. But just as a reminder, because this x minus 4 is obviously not going to cancel anything upstairs, I know it's an asymptote. All right, so x minus 1. So we're going to plug in a number really close to 4. Since we're approaching 4 from the left, and that's right here, let's pick a number right to the left of 4. And we know we have an asymptote through 4. So let's pick a number right next to the 4, just to the left of 4, since we're approaching 4 from the left. And I'm going to pick 3.99, because that's what I always do. So now if I plug in 3.99 for x, I'm going to get 3.99 squared, and then 3.99 minus 4. Now this one upstairs, 3.99 squared, if you don't have a calculator, don't worry about it. You can see the top, whether that's 3.99 or 4 or whatever, that top is going to be a big positive number. It's going to be like 16 minus 1 is 15. So if you plugged in 3.99 instead of 4, maybe you'd get 14.98 or something. But the point is that upstairs is not where the magic's happening. The magic's going to happen downstairs, because that 3.99 minus 4 is going to give us a minus tiny number. A positive number divided by a negative number gives us a negative number, and a big number divided by a tiny number gives us a big number. So this is going to be negative 1,500. So obviously a really big number, but like I said, all we have to do is pick between this and this, and since I got a negative big number, I know the bottom one must be right. It's not positive infinity, it's negative infinity. So that's how we do it. We plug in a number really close and on the same side of the number as what we're looking for. All right, last one. This one's a little bit different. There's no asymptote in this problem. So I picked this function just because it's kind of a wacky one that has a wacky graph. We're not actually going to graph it until maybe at the end I'll show you what was going on. But once again, plugging in a number that's really close to the number you're curious about is the key. So since we're approaching 2, and notice 2 would be the number that of course makes us divide by 0, so it's really annoying. We're going to plug in a number that's really close. So since we're approaching 2 from the right, since we're approaching from the right, because that little plus sign, I want to plug in a number that's just to the right of 2. So that's going to be 2.01. So we'll plug in 2.01, absolute value 2.01 minus 2, over 2.01 minus 2. That's the absolute value sign, not 21. So 2.01 minus 2 is 0.01. And then 2.01 minus 2 is 0.01, which equals 1. All right, so the limit approaching 2 from the right is 1. What happens when we do approaching 2 from the left? Well, now I need to plug in a number that's just a little bit to the left of 2, right? So it'll be just a little bit to the left of 2, like 1.99. So now we'll do absolute value of 1.99 minus 2 over 1.99 minus 2. Now here's where the magic's going to happen. 1.99 minus 2 is actually negative 0.01. You see last time we got positive 0.01? But now we're going to get negative 0.01 because we're subtracting 2 from a number that's a tiny bit smaller than 2. But what do my absolute value signs do? They make that positive again. So I end up with a positive 0.01 upstairs because my negative 0.01 had absolute value signs around it. Downstairs, I have the same situation except no absolute value. So I end up with a negative 0.01 downstairs. So what's 0.01 over negative 0.01? Negative 1. Pretty cool. So the limit from the right side is 1, and the limit from the left side is negative 1. And it's going to turn out that if you're approaching from the right, like we did in this first one, doesn't matter what number you plug in. You could plug in 3. You get 3 minus 2 is 1 over 3 minus 2 is 1. The x minus 2 is just kind of cancel, right? So it turns out no matter what you plug in, you're going to get 1 So this graph looks like this. It just shoots off to the left, like to the right, like that. This downstairs one, no matter what number you plug in for x, we already tried 1.99, but if we plugged in 1, we get 1 minus 2 is negative 1. We get to absolute valued. Bottom doesn't. So again, the x minus 2 and x minus 2 pretty much cancel out to a 1 all the time, except because the top will be positive and the bottom will be negative, it's always negative 1. So the graph of this thing going left looks like this. And then at 0, this thing at exactly 2, this thing is undefined because you can't divide by 0. So that's why we have 2 open dots, and there is no solid dot for x equals 2. All right, so that's the graph. And of course, just to remind you, when the left hand and right hand limits do not agree, so we got one coming in at a positive 1 and this other one coming at negative 1, they're not going to collide. So this limit does not exist. Or you might even write no limit, because really it's not like this is infinity of the limit. It really doesn't exist because left and right don't match up. So anyway, as you can see, for left-handed and right-handed limits, if you just plug in a number that's really, really, really close, that'll give you a really, really, really good idea of what the limit should be. Just remember that if you get a big number like 200 or 2000, you should think of that as infinity because it just passed 2000 on its way to infinity. Or if you get negative 2000, the limit is negative infinity because you happen to be at negative 2000 right now, but in a split second, it's going to be even further down. So just keep that in mind, and I'll see you in the next video.